We'll start the session at 6:10. Let others join if someone is joining. Hello everyone. So first I'll share my screen first. Let me share the screen first. I hope you guys can see my screen. Okay, no, not this one. Okay. Hello everyone. So today we are going to discuss about the week 11 lectures. I hope you guys have gone through the lectures. So as you are seeing that as weeks are increasing, number of videos are also increasing. But don't get scared because the assignment questions are not that very difficult. Okay, so today we'll be discussing about all the lectures that we have seen in the week 11 lectures. So hello all, I am Balram Shah. I'm the PMRF TA for this course, that is Optimization Methods for Civil Engineering. I'm a PhD scholar at Interdisciplinary Center for Water Research at ISC Bangalore. So let's start. But before that, so what all we have discussed in the last tutorial sessions were Okay. So we have discussed about the genetic algorithm. So we have started with the classical optimization, right? So after we have seen what are the necessary conditions, sufficient conditions, and how we can solve one optimization problem with different methods. So those were in the classical optimization. From there we moved to meta heuristic optimization, and in that we have seen there are several algorithms, several methods that are there in meta heuristic optimization. One of those are the evolutionary algorithms, and in evolutionary algorithm we started with the genetic algorithm, right? In genetic algorithm we have seen what are the method, like how is the algorithm working. So what are selection operator, what are mutation, then crossover operators, and how to initialize the population, and so on. And then we have seen how to do encoding in the genetic algorithm. We have seen binary encoding, we have seen real coded encoding, and so on. So with that we can reach the solution or the optimized value of the function that is given. So those were for the single objective function, right? After that we have discussed about the swarm particle swarm optimization also, in which we have seen that it, so all these evolutionary algorithms are based on the theory of evolution, which was given by Charles Darwin, obviously, right? So with that we have seen genetic algorithm, we have seen then particle swarm optimization, right? So those whatever we have seen for single objective function. And in the classical optimization method, I hope we have done the multiple objective optimization also. So in that what happens that we have more than one objective function. So in the week 11 lectures, in the beginning also you must have seen what is multiple objective function. So let's say for example you want to buy a phone. Yeah, right now I'm not sharing the screen. I'll explain what is multiple objective optimization, and then I'll start. Okay. Yeah, so what all we have seen, we have so for example let's say you are going to buy a new phone, right? So in that what you will see several specification. Okay, you will see, okay, what is the price for this phone. Then you will see that what are the specifications, such as you want to see the camera. Okay, is it 108 megapixel, or it is like some in the range, right? Then you will see what are the processor, is it what kind of Snapdragon it is, and so on. So here when selecting a phone or when buying a phone, you are seeing you have different objectives, that the price should be in this range. So that price should be in this range is one of the constant, where the objective function is buying the phone, right? So in that you will have different variables, such as you will have the price, you will have the camera specification, you will have the processor specification, you will have the battery specification, and so on. So here I have mentioned four of the objective function, four of the objectives, right? So the objective should be that price range should be this, and then battery should be between this and this mAh, and then processor should be between this and this. So these are some of the objectives, and that can come up with some of the constraints, so that we'll discuss, right? So let me start with the lecture given by sir only. I'll switch off the video so that bandwidth will be fine. Okay, so he started with the example of maybe car also. Here also you can see for any car what will you see, you will see the price, or let's say comfort. So these two things you are seeing. So these are the two objective functions that you can think of. Okay, now what you can see, this line that you can see, so for any of the function that we are going to deal, it is called as Pareto optimal front. Okay, so we'll see what is that. Okay, so you can see on this line, so these maybe this car is having less price but less comfort also. This is having a little bit higher price but equal comfort is there. So in this line whatever will be there, those will be the non-dominated solution. So what is non-dominated and dominated, we'll discuss that later. But before that, what all we have discussed, that a multi-objective genetic algorithm. So here whatever multi-objective optimization we'll see. So in classical optimization we have done multiple objective optimization. Now we'll do the same thing but using the genetic algorithm. So as you can, from the name only, it suggests that it has more than one objectives. and objectives can be conflicting in nature. So let's say for any water resource problem, what you can have, let's say you want to irrigate one field, right? So there you can have like this much amount of water you have, so that you can irrigate the field. Also you have the area of the field that to be which need to be irrigated. So that kind of objectives can be there, and sometimes objectives can be conflicting also. Okay, so here in this algorithm, whatever we'll see, we'll have two search space. So what are these search space? Here you can see that two search space are there. So first search space, whatever you can see, are the decision variables search space. So let us say that objective function, whatever objective function you have, are having two variables. Variables are x1 and x2. Okay, so it can be like first function, that is f1 can be, let us say, x1 square plus x2 square, and f2 is another objective function which can be, let's say, 4x1 minus 3x2 plus e to the power x1, something like that. Okay, so we will have one search space for decision variable and one search space for the objective function. And also you should note that, let's say if this point, okay, if I can make it some, okay, fine, that's fine. So let's say you consider any point here in the search space, okay, for some x1, let's say at x equals to 3 and y equals to, or x2 y equals to 0.5, you will have one point. Okay, and let's say at x1 equals to 2 and maybe x2 equals to 0.3, you will have a point. Now if you project that point in this space, okay, so what we are doing, we are projecting from the search space to the objective function space. Okay, so here it is not always applicable that, see here it is written that proximity of two solution in one search space does not mean a proximity in another search space. This means what? If two points in the search space or the decision variable search space is smaller, that doesn't mean that in objective function the points which corresponds to those points in the search space will be equal. So if it is smaller, it can be larger, it can be smaller, it can be same also. Okay, other than that, it is having a unique mapping between the objective, and often the mapping is non-linear, properties of the two search space are not similar, and so on. Okay, so this multiple objective genetic algorithm, for example, as I was mentioning, let us say we have two variables, that is x1 and x2. Okay, so now from this what we have two objective function which need to be maximized. So both of the function needs to be maximized. Before that, whatever we have dealt with are one objective function only, so we'll have only one objective function and there will be several constraints to which we need to optimize. But here we have two optimization. Okay, so many a times it is not possible that you always want one perfect solution, perfect as in perfect optimized solution. It is not necessary always that it will have one perfect solution. So when you are doing this multiple objective genetic algorithm, you have to compromise on one of the objective function. So it can be possible that on both of the objective function you are compromising, something like that. Okay, so let's say you are giving 60% to the first 60% importance to the first objective function and 40% importance to the second optimized objective function. Okay, so like that we'll see. Okay, so these are the two objective functions with two variables, that is first one is 1.1 minus x1 and second is 60 minus 1 plus x1 by x2, and it has two constraints, that is x1 is the range space of x1 and x2. Okay, okay, so let's see some of the methods that we can use as a genetic algorithm method to solve this kind of multiple objective algorithms, multiple objective optimization problems. So here we can see that one is vector evaluated genetic algorithm. Okay, so here what we do, so for example, okay, if you don't see this also, it is easier here, you can understand here. So let's say what is given, that x1 varies from 0.1 to 1, right, and x2 is given as it varies from 0 to 5. So we'll make a table, let's say. So we have initialized a population, so it starts from 0.1, 0.1, 0.3, 0.5, 0.9, 0.25, 0.45. So like that you can initialize a population, but remember that x1 should lie between 0.1 to 1, and again x2 some of the population which lies between 0 to 5. So we have just initialized some population randomly. Okay, now for this x1 and x2 we can calculate f1 and f2, right? Because f1 is 1.1 minus x1, so just put this x1 value and you get the f1. Okay, similarly you will get the f2 values. So for this randomly generated population, initial population, you can calculate the corresponding two objective function values, that is f1 and f2. Now in vector evaluated genetic algorithm, what we do, we divide these population into sum of the population. So let's say if you have two functions, what you will do, will give sum of the population for the function 1 and sum of the population for population function 2. Okay, so here you can see what we are doing, we are writing partition as in which combination we are giving in function 1 and which combination we are giving in function 2. So you can see the first combination, second combination, we are considering that. So this whatever we are doing here, we'll do it randomly. Okay, so here 1 and 1, so 1 and 1 means this is the function 1 and this 2 refers to function 2. Okay, so like that we have randomly selected the first two as the for the function 1, next 3 as for the function 2, and last one as the function 1. So let's say if here you will have 3 function, then what we will do, will, let's say we anyway we can't just work on this small population, we have to create a large population so that we can reach to the optimal solution properly. Okay, more accurately. So let's say if these many population only you have created, but you have 3 functions, then what will we do, we'll divide this into 3 functions. So maybe 1 1, then 2, then 3, again 2 and 3, something like that. Okay, now we'll assign the fitness value, because each of the, as I mentioned before, that these objective function is considered as the fitness function, and with this fitness function only we proceed. So we'll assign some fitness value. So how we are assigning the fitness value, so this one is for function 1, right? So we'll take directly the function 1 value, so that is how much, 1, so we are just putting 1. Then again function 1, so we are taking the function 1 value, that is 0.8, so we are putting 0.8. Then function 2 is how much, 59.25, so we are putting 59.25, and so on. Now we have got the fitness value. After this, it is very similar to whatever we have done for single objective genetic algorithm. So what we will do, now we have the fitness value with us, we'll use the operator such as selection operator, elitism operator, then crossover operator, then mutation operator, and till the time the termination criteria is not satisfied, we'll keep iterating that unless and until the termination criteria is fulfilled. So let's say if you are considering, okay, this much error we can take, so that, and then whenever after these many iteration we are reaching to that error, we'll stop that algorithm. Okay, I hope this vector evaluated genetic algorithm is understood. Okay, so now we'll move to some of the more methods. I'm not going very deep into this now because we have more methods to discuss. Okay, so this is one of the important method, that is non-dominated selection heuristic. So this is if we are doing genetic algorithm, then it will be non-dominated selection genetic algorithm. It is also called as NSGA in short form. Okay, so non-dominated solution and dominated solution, first we will understand that. Okay, there should be one figure. Yeah, so here you see in the beginning we were seeing one car examples, right? So like that, let's say you have how many solutions, 6 solutions, let's say. Okay, so here how many solutions we have 6 solutions. We have, this one is the first objective which need to be minimized, and this one is the second objective which needs to be minimized. So again we have 2 objective optimization problem, and now we have different solutions. So those solutions are 1 2 3 4 5 and 6. Okay, now in this what we do, we understand first what is the non-dominated solutions. Okay, so here if you see the first point, that is point 1, in this objective 1 is minimized, but objective 2 is maximized. Okay, but no none of the solution is dominating this point, so this point is one non-dominated point. Again if you see 4, okay, now if you see point 4, this point 4 is having less objective 1 value, but objective 2 value is more than that of this point 2. So this means what? This point 4 is dominating which point? Point 2. So this means what? Point 4 is a dominated point solution and point 2 is a non-dominated solution. Okay, whereas again if you see point 5 and point 4, so see point 5 is dominating point 4 in both the direction, in both the objective function. That is, if you see here, 4 is here, right, in objective 1, but 5 is here in objective 1. Whereas in objective 2 you see the point is here, but point 5 is here. So point 5 is more than that, but what is our goal? Our goal is to minimize. If this would have been maximized, then 4 will be dominating 5, but here what is happening, as is it is a minimization function, 5 is dominating 4. Okay, so similarly if you see point 6 is dominating point 2, hence point 2 is non-dominating and point 6 is a dominating point. Similarly if you see 3, so 3 is in objective 2 it is very the minimized one, but in objective 1 it is a maximized. So this is also one non-dominated solution. So if you see here, see in non-dominated sorting an individual x, okay, so x and y are the two individuals. Okay, so let us say if you say this point is x1 y1, let's say, so this there x1 and y1 are the individuals for the population x. Okay, so in non-dominated sorting an individual x is said to dominate another individual y if and only if there is no objective of x worse than that objective of y. So first condition, if you see 1, 2 and 3, if you see, the first condition is satisfied. Second is if there is at least one objective of x better than that of objective of y. So now if you see 2 and 6, okay, in objective 1, in objective 2 anyway it is same, right, but in objective 1 6 is dominating 2. This means what? So this 2 is having one objective of like x better than that of 6. So this is one of the non-dominating point. Okay, so that was for how to understand which one is dominating and which one is non-dominating point, right? So I'm not going into all this. So what we do, we subtract epsilon. So let's say if there are these points are there, okay, so I'm only right now I'm talking about NSGA only. NSGA 2 is also there, that all also we'll discuss. So here what we do, so 1, 2 and 3 are the non-dominating points. Now what we do in NSGA, we subtract these points with some value, let us say epsilon, so that we move this dominated solutions to non-dominated solutions, so that we can optimize that. If you see one figure was there, yeah, here you see what is the first goal. First goal is to push all the solution to the Pareto optimal front. Okay, Pareto optimal front is the front or the line or the line joining the points where all the non-dominated points are there. Okay, so this is the first goal, and second goal is to maintain good diversity. This we'll see when we are doing diversity and all. Okay, so what we are doing, we are subtracting this epsilon from the from the dominated solution so that it reach to the non-dominated solution. And so this method has two implications, that non-dominated solutions are given more importance, and what we are doing, additional equal emphasis has been given to all the non-dominated solutions, right? So what we do when we have more than one functions, we give weights to each of the function, let's say. Okay, so in this example whatever you have seen, so in this what if we have given the whole weight to 1 and we have kept 0 weight for the second function. Okay, so like that what we can do, we can give weights to each of the functions. So let's say if you have two functions, so first function you are giving a weight of 0.9 and second function you are giving a weight of 0.1, and like that you can do several combinations, and then you can calculate the fitness. Again, this shading function and niche count we have studied earlier in the earlier lectures. So why we are using this shading function? This shading function is used so that we can understand the spread, right? So this dij, you know, is the distance and all, right? So I'm not going to discuss all this because we know all those things. Niche count, if you know, if niche count is more, then it will be more crowded solution, whereas if niche count is low, this means the points are less crowded. Okay, so we have discussed all this. So what we are doing, sorting based on, or what we are doing, see, they assign fitness value based on the non-dominated ranking, so we are sorting based on the ranks. Okay, so how we are assigning the ranks? We are assigning the ranks based on how many number of solutions are there which are dominating that solution. Okay, so here you can see this point, this point, this points, and these points, these are only, so there are no solutions which are dominating this point, right? So ri will be equals to 1 plus 0, so that is 1. So like that you can get for each of the point, and then you can rank it. Okay, and then you can put fitness value to it. Okay, so these all I'm not going. Yeah, so in this NSGA, what we have seen, we have seen that we are considering some parameter, that is niche count, to understand the crowdness and all, right? So this is one of the disadvantage of using NSGA. So this Professor K. Kalam Dev and his students from IIT Kanpur, they come up with a modified version of this NSGA. Okay, we call it as NSGA 2, let's say. So in this, what happens, NSGA 2 can converge to the global Pareto optimal front. So what we are doing, firstly we are converging to the global Pareto optimal front, right? And second, what we are doing, it can maintain the diversity of population. This diversity of population was disadvantage in the NSGA, right? So it can also maintain the diversity of the population on the Pareto optimal front. Okay, so these all we have discussed, what is non-dominated sorting and all. So now if you see this, so this circle whatever, or ellipse whatever you can see, let's say this is one of the constraints to both the functions. Okay, so if any solution is there inside this constant, this means what, this is a feasible region, and the solution inside this are called feasible solution. Whereas if any points, if you see outside this function, that is infeasible, so any points outside this is called infeasible solution, right? So this 5 and 4 are infeasible solution, whereas 1, 2 and 3 are the feasible solution. Even if this, if you remove this constraint, what will happen, 5 is one of the non-dominated solution, because it is also minimizing objective 1, whereas it is also minimizing objective 2, but the constraint is applied, and hence we can't choose this point, because this is now an infeasible solution. Okay, so here from this 1, 2 and 3 we have the feasible points. Okay, yeah. So in this NSGA 2, how we are calculating the crowd? So in the NSGA, what we have seen, we have used the niche count, right? So here we don't use niche count, we use crowding distance. Okay, so what is crowding distance again? So how do you calculate crowding distance? This crowding distance will give you that how much crowd it has. Like what niche count was doing, it will say that if niche count is more, this means the crowd of the points are more. The points are more crowded at that location. Similar thing, this crowding distance is also doing. Okay, one more thing I didn't mention in the NSGA was, so in this what was happening, that whenever we are doing this vector evaluated genetic algorithm, so whatever we are doing, it is only applicable for the extremes. So let's say if this is the, let's say, Pareto optimal front, okay, then the whatever we are doing, it is only applicable because we are, let's say we are maximizing two functions, this maybe deflection and weight. Okay, for example, then because we are maximizing both function, the points will be either lying here because it is maximizing which function, the second function, whereas, or the points will be lying here. So whatever we are doing from whatever we have studied before in SGA 2, what it is doing, it is only converging it here, only here, at the extremes, either maximum. Okay, so in that case what is happening, we are not having diversity because all the points are crowding and getting crowded here or here, right? So we need points everywhere, so we need diversity in our solutions, right? So for that we use an SGA 2 also. Okay, so to understand the crowding distance, what we are doing, so let's say these are the points or the solutions. Now what we do, we make rectangle kind of thing. So let's say if this is a point, I minus 1 is a point and I plus 1 is a point, what we do, we make a perimeter or line starting from I minus 1 till I plus 1. Okay, and again we create a line from I minus 1 to I plus 1 in both the direction, and then we are joining. So then what is happening? One rectangle kind of thing is getting created by the two neighboring solutions. So this is the solution, let's say I, and now you are want to find the crowding distance here. So what will you do? You will consider two neighboring points, that is I plus 1 and I minus 1, and then you will create one rectangle. Okay, now what do you think? If this rectangular area or the perimeter is more, this means what? If perimeter is more, whether the crowding distance will be more or less? Perimeter more means the rectangle will be more. Rectangle will be more means the neighboring solutions are at a very far distance, and hence the crowding distance will be very low, and hence the solutions are very less crowded. So this means what? If the CD value is high, this means the solution is less crowded, whereas if CD value is less, this means the solution is more crowded. Okay, so this tournament operator. So simply after that we are doing similar operators. We'll be using selection operator, crossover, mutation operator. We'll also use uh, elitism here. We'll keep the good solutions, and then based on that we'll again do this. Okay, so these are all whatever multi-objective genetic algorithm was there. Okay, so we'll see some of the questions now. So other than multi-objective, what all we have learned in the week 11, we'll also see one more meta-heuristic optimization, that is differential evolution, after some of the questions, and then we'll move to the MATLAB to do some of the introduction of the MATLAB and some of the problems that we have done in the R. In R we have done only generic algorithm, so we'll start with classical optimization. We'll see that, but let's go to the questions first. We hope you can see the screen. Okay, so the first question is the vector evaluated genetic algorithm used for solving multi-objective optimization problem. Okay, so which one is correct? Attempt was made to obtain Pareto front of solution directly. The concept of non-domination was used. Weight sum approach was implemented through a GA, in which the weights were selected artificially, or the concept of ranking was used. Let's go through the whatever we have just now. We have seen this. Okay, anyone? Let's see if you guys having any problem in talking. You can give and write it here. Okay, fine. Yeah, so see, whatever we have discussed in this vector evaluated generic algorithm, we have seen that what we are doing, So we are giving weights to each of the function, and then we are doing sum, right? You remember that 0.9, 0.1, and then like that we are doing several combinations. So this concept of non-domination and all will be there, in which weights Pareto front observation. So the correct answer will be C, right? Okay, let's move on to the next question. So the next question is in non-dominated sorting, an individual X is said to dominate another individual Y. So this we have just seen. So let's say if I've just seen that, but still if you want I can explain that. Give me a minute. It's not B, it's like, okay, I'll explain first again. Okay, give me a minute first. I'll connect this so that I hope you can see this screen now. Okay, so what we have seen, so here the question is, let's say you have two functions. Okay, two functions. Okay, now what is the question? In non-dominated sorting, an individual X is said to dominate another individual Y. Okay, so let's say there is 2 points. Okay, so this is, let's say, x1 y1, and this is, let's say, x2 and y2. Okay, now what we can see, so let's say if this is a function f1 and this is a function f2, so now you see the first point, let's say a and b. If I write the first point a, and let's say you want to minimize both function. Okay, now this point a is said to be non-dominated. Why? Because here see, what are the options? If there is at least one objective of x better than the objective of y. So here you can see that point A is, the objective of f1 is better than that of objective of point B, right? Because here, let's say if the value is 1 here and the value is 2 here, okay, the function value means the value of f1. So here what you can see, we have to minimize, and hence 1 is better than 2. So the point a is better than b in which function? In the function f1. Okay, so if there is at least one objective function, objective of x better than objective of y, and hence here a is correct. Next is what? If and only if there is no objective of x worse than that of objective of y. Okay, so here if you, let's say if you are making another point also, let's say here somewhere, here you see
if you compare with any point, maybe a b, any point, then you can see that ob objective of x, maybe a, is not worse than that of objective of y, because a is better than c and b is also better than c. So in this case b is a non-dominated sorting. So if you sort, so which one will be at the first? It will be a, then b, then c, right? If you sort it, right? So the correct answer will be c, that is both a and b. Okay, I hope this is clear.
Yes.
Okay, right, so we'll move to the next question. If the crowding distance value is less, this means what? So crowding distance just now we have discussed. So let's say if two functions are there, that is f1 and f2, and you have made several points for the optimal front, then let's say if this is the point I whose crowding distance you want to know, then what will you do? You will draw a rectangle for the two neighboring points, that is I minus 1 and I plus 1, let's say. Okay, so okay, now if this perimeter, the perimeter of this rectangle, will give you what? The crowding distance. So let's say CD is the crowding distance. Now if the perimeter is less, this means what? The neighboring points are very closer and hence the solution is more crowded. And here what is the question? That crowding distance value is less. This means what? That the perimeter is small and hence the solution is more crowded. So the correct answer will be B. Okay. Okay, so we'll move to the next question. Next question is in the differential evolution. Okay, so for this we have to understand differential evolution. We'll see that differential evolution first and then we'll come here. Okay, I hope you guys see the screen. Sorry, where did I keep that? Okay, so as I mentioned that we'll also discuss about the one of the other meta heuristic optimization, that is the differential optimization or differential evolution. Okay, so differential evolution is one of the meta heuristic optimization method. Okay, so this differential evolution can be used for getting the solution for the optimization problem. Even if it is linear problem, we can do that. Even if it is non-linear problem, we can do that. Even if it is non-linear problem with constraints, we can use this approach, that is differential evolution approach. Okay, so here it is mentioned that it is a stochastic population based optimization algorithm for solving non-linear optimization problem. Okay, so here we are considering, let's say one objective problem is there, so we are only considering single objective now. Okay, so we have single objective function, that is f of x, where x is a vector having different population, that is x1, x2, x3 up to xd, where d is the number of variables. Okay, so these are different populations and d is the number of variables. So here also, similar to whatever we have seen in genetic algorithm, we will be doing, but there is some difference. So here we are not using any selection operator. Oh, sorry, here we are not doing any crossover operator. Okay, so whatever solutions we are getting, we'll use those. Okay, so what we are doing, similar to the genetic algorithm, will initiate a population. Okay, then we'll do mutation. This mutation is again different from the mutation we have studied in the genetic algorithm. Okay, then we'll do recombination, then we'll do selection, and then based on all these operators, if the solutions again is satisfying the transformation criteria, it's fine, we'll get the optimal solution. Otherwise we have to iterate it again. Okay, so here you see what we are doing. In the beginning only it was mentioned that it is a stochastic population based optimization algorithm. So we have to consider some population size. So we are considering, let's say, a population size of capital N, and hence the population matrix can be shown as xng, where small n, whatever you can see, is the let's say if your population size is 1 to n, capital N, then 1 2 3 4 5 6, all this is denoted by this n, and g is the generation. Okay, generation as in will keep iterating, right? So number of iteration is considered here as generation. Okay, so xn1g, xn2g, and so on. And d is the number of variables. Now, starting from the first step, that is initial population. So what we are doing, we are going to initialize a population. So how we are going to do that? So let's say we are initializing a population randomly between the upper lower and upper bound. Okay, so upper lower and the up sorry, it is not upper lower, it should be lower and upper bound. Okay, so it will be, so whatever population we are writing, so let's say you know the lower bound of x. Okay, so that lower bound, that is x, this capital L denotes the lower bound. Okay, and the difference of the upper bound and lower bound into the random value, and this random value only will help us to create or initialize a population. And this random values, how we are getting, we are considering one uniform distribution from 0 to 1. So whatever value will be there, it will be from 0 to 1, and then based on this lower and upper bound of the population, we can generate an initial population of whatever size you want, right? So here again it is written that xli is the lower bound of the variable xi, and xui is the upper bound of the variable xi. Okay, so now let's say we are done with the initial population. So what we got a initial population. Now we'll use this initial population and we'll go for each of the operators, that is mutation operator, recombination operator, and selection operator. Okay, so here see what in mutation what we are doing, we are doing we are getting a donor vector. Okay, how we are getting a donor vector? Simply xgr1 plus this f is a value. Okay, f is a value, or you can consider as a weight given to this. Okay, so from the initial population what we are doing, we are mutating the solutions to get new solutions, right? So this new solution is called as the donor vector. Okay, so what we are doing, adding the weighted difference of the two vectors to the third. So this is the, let's say, one vector, or the one vector whatever we are seeing, and the difference between these two, and we'll give a weight. So this f is considered as a weight. Okay, and then we are getting a new solution. So this is also kind of mutation. What is the main purpose of mutation? To get a new solution. So here also we are getting a new solution. So this new solution is called a donor vector. The value of f can be between 0 to 1, or sometimes it can be 0 to 2 also. Then we will go for recombination. In recombination what we are doing, a trial vector is developed from the target vector and the donor vector. So this donor vector from where we got from mutation. Okay, and now we are having one target vector. Okay, so using this target vector and donor vector, we'll develop one trial vector. Okay, so how we are getting this trial vector? The trial vector is equals to the donor vector if the random value whatever we have generated is less than cp. Again, this cp is kind of recombination probability. Remember, in genetic algorithm also, when we were doing mutation or when we were doing crossover, we have one crossover probability or mutation probability. Like that, we'll have one recombination probability based on maybe experience or the functions or whatever we have, based on the problem. Okay, and if I equals to I of the random number, then we'll use the donor vector. Otherwise we'll use the target vector. Okay, and random, again this random number is generated as from a uniform distribution between 0 and 1. This is a integer random number between 1 and d, and so on. Okay, so I'm not going very deep, it's easy to understand. So then after doing mutation and recombination, what we are doing, we are doing selection. Okay, so let's say if you have the target vector, you have the trial vector, we'll compare those. Okay, and whoever will have the lowest function value will be selected. Okay, so why lowest vector? So whenever we are doing minimization, then the lowest function value will be selected for the next generation. Okay, otherwise whichever is lower between those two, we'll consider that. Okay, then there will be some termination criteria. So let's say you will consider, okay, this much error is enough. Okay, so whatever termination criteria will be there, based on that you can reach to the optimal solution. Otherwise you have to iterate it again and again unless and until you reach the termination criteria. Okay, so these are some of the question the explanation for differential evolution. So we'll see one question first, and then we'll move to the R to do this what to say differential evolution. So these all we have discussed. Okay, so the question is, in the differential evolution, if the donor vector is 4, 3 and 10 and the target vector is 3, 8 and 9, which of the following can be a trial vector? So what we have discussed just now, okay, I'll show in this so that I can explain, or else fine. No, fine, I'll explain here. Okay, I hope you can see the other screen. Okay, so the question is, if the differential evaluation, or if the differential in the differential evolution, if the donor vector is, so donor vector is given as 4, 3 and 10, right? And target vector is given as, let's say, 3, 8 and 9. So we need to find out the trial vector. So how the trial vector can be? The trial vector can be between this and this, and again it depends on the probability, recombination probability, and then random value and all, right? So let's say if these all we know, then what will happen? Based on this donor vector and the target vector, will get to the trial vector. So any number which is out of these numbers will not be the trial vector, right? So if you see the first one is what? 4, 4 and 10. So first one can be 4. So see, in the first place of both the target vectors and donor vectors, 4 is there, so 4 can be possible in the first place. Second is again 4. So but see here, in the second place it is 3 and 8. Okay, so in the second place it is only possible that it can be 3 or 8, right? But in this 4 is there, so this is not possible, so this option is not correct. So like that, if you just compare that which can be one of the trial vector, can you just tell me which one will be the answer? Okay, any answer? See, what I said, that if any trial vector is there, it will be only in the combination of these two. So in the first place it can only be either 4 or 3, because in the first place you see only 4 and 3 are there, right? In the second place it can only be 3 or 8. In the third place it can be only 10 or 9. So with this combination, is there any answer is there? Yeah, see, if you see, because you see here 4, 8 and 3 is there, so 4 is possible, 8 is possible, but here 3 is not possible because only 10 and 9 is possible, correct? So the correct answer will be 3, 3 and 10. Okay, I hope this is clear. Okay, we'll move to the next question then. So okay, next question is in MATLAB. Okay, so we'll move to, first we'll solve one optimization problem in R using this differential algorithm, and then we'll move to the introduction to MATLAB. I hope till now everything is clear. Okay, okay, so anyway, we have seen this R for maybe 1 or 2 tutorial sessions now, so we'll just rush through it. So you know that so what we are doing now, we are solving the optimization problem using differential algorithm. So the library package that we use for solving the differential evolution is DE Optim. Okay, so just for like, if you want to call this library, before that you have to install this package. So either you can install it like this, install.packages and DE Optim, and if you just run this line, you will get the uh, this package, that is DEM. Or if you can go hit here in packages, and then you can just search here, or maybe if you just click on install, you can write the package name here and you can install those. Okay, anyway, I have installed this, so I'm not going into that. Okay, so for using that, what you have to do, you have to call that as library and deoptim. Okay, if you run this line, you know that if you press control enter, it will run that line. Okay, okay, now these we know. So this we have seen so many times, that this is for the writing the function, then keeping. Okay, I mean, I will go through once. So this f1 we are considering, let's say, one variable in which we are storing the function. This function is having two variables, that is x1 and x2. And now if we are writing x1 comma x2, this means what? We are considering x1 and x2 as scalar units. Okay, now the function is x1 square plus x2 minus 11 whole square plus x1 plus x2 square minus 7 whole square. Okay, so this is the function. Now what we have to do, we have to create or values for x1 and x2. So what we are doing, so x1 and x2, we are creating a sequence from 0 to 5, and the sequence will start from 0 and it will go by 0 0.1. So it will be 0, 0 0.1, 0 0.2, 0 0.3, and it will end at 4.8, 4.9 and 5. Okay, z is what? Z is this function, that is f1. So z will store the function value, this function value, that is x1 square, this function value. Okay, so x1 comma x2 comma f1. So whatever f1 function it is taking, and it is storing the value in this vector, that is z. Okay, and with this PRSP, what will you get? You will get the 3D plot. Okay, first we'll just run these lines. Okay, and next, okay, you can't see this property, right? So here you can see we have x1 and x2. X1 again starts from 0, 0 0.1, 0 0.2 and so on, and again x2 also starts from 0, 0 0.1, 0 0.2 and so on. And z also, you can see z we have calculated, and the values, if you put 0 0, then you'll get the function value as 170. If you put 0 0.1, 0 0.1, it will get 168 and so on. Okay, we got z. Next we are plotting this line. Okay, control enter. See, you got the 3D plot. Okay, this is x1, this is x2. If you want to see it, you can give phi value and angle value, right? That we have seen in the last class. If you want contour, you can just plot it like this. See, you got the control. You can put it here x label and y label. If you write x lab equals, let's say, x1, and y label equals x2, let's say, right? And if you just run this, see, you got the x label and y label as x1 and x2. So this is the contour plot. This much we know, right? Now what we are going to do, we are going to optimize this function. This is the objective function, right? So we'll just write that again, but here in the vector form. So x is having a vector with two elements, that is x1 and x2. And how we are calling that? X of 1 means x1 and x of 2 means x2. Okay, so the function, how to write this all and all, we have discussed in the last class. So now we'll directly call the d-optim, that is differential evolution. Okay, optimization. So here we are putting this function fn. Okay, the lower bound is 0 and 0 for both the x1 and x2, and upper bound is 5 and 5 for both the x1 and x2. Okay, so we have run this line. No, na. Okay, we'll run this line. Control enter. This is okay, x is not fine. What happened? It's fine. So we have got function fn, right? Next we are doing this. Okay, if you just run this line, you'll see we have got the, we have not mentioned these iterations and all. So default iteration number is 200, and we are getting the values as 3 and 2. Okay, now if you just want to see the summary also, you can just run this. See, best member is what? 3 and 2. X1 is 3 and x2 is 2. And the best value is what? Best value is the function value. So the best value is 0 because we need to minimize the function, and it will be where? Here, 3 and 2, here, somewhere here. Okay, and getting points, plotting points, putting lines and all we have discussed in the last class, so we are not going to all those. And you just want to plot these results. See, you can see, right? X1 is starting from here and then it is moving in iteration. If I zoom, I can see it properly. See, it starts from 0. In this iteration it is moving like this and this, and after that it is getting converged at 3. Okay, similar to pair 2 as in second variable, that is x2. Okay, so this was one function. Similarly you can do for any of the functions. So just to show, here I have shown you another function. The function is 10 plus x1 square plus minus 5 x1 x2 plus 9 x square x2 square plus x2. Okay, we'll just run this line because you guys just know this. Sequence starts from minus 5 to 5 and so on. Okay, run, and then maybe this function we are writing in. So see, here you can see the 3D figure and the contour plot. Anyway, now we'll run this line. So see, iteration is 200, number of iteration. Best value is how much? 9.909 something, and x1 is minus 0.4545 something, and x2 is minus 0.18. We'll see the summary for proper. So here x1 is this much, x2 is this much, and the best value or the function value is this much. Okay, if you just want to plot, you can just plot it. See, you can see the parameter values. Okay, I hope this differential evolution is clear. Okay, we'll move. Any question till now? If not, we'll move to introduction to MATLAB. Okay, I'll consider that as understood. Okay, so I'll not show the installation and all, that is just easy, you can just go through it. So here we can see that here we'll be doing the editing. Okay, and here we can see the command window, we can see the workspace, here we can see the plots. That you can just go to the layout and change based on whatever layout you want. Okay, just like whatever we did in R, we can do it in MATLAB also. Okay, so today what we'll be seeing. Okay, first I'll increase the font so that it is clear. I hope it is properly visible. Okay, so here whatever we have done in the introduction to R, we can do here also. So you can do all this in R, you can do it in MATLAB, you can do it in Python. Okay, depends only on library, what library you are using, and the syntax for each of the languages will be different. So just you need to understand whatever the fundamentals are behind those. Okay, how it is happening, so that you can write a code based on that. Just the syntax will be different and the packages that you will be using will be different. If packages are not there, you can just develop a package of your own. This all we have discussed, right? So you can do addition, subtraction, whatever you want. Okay, so this CLC will clear everything. So just if you want to just run one line, okay, then you can just select that and you can press F9. Okay, wait. Okay, so we have just started the introduction to MATLAB. So what I said, that we can, whatever we have done in introduction to R, we can do that in MATLAB, we can do that in Python, just that the syntax for each of those will be different. Okay, so you can do addition, subtraction, whatever you have seen in R, you can do it here also in MATLAB, you can do it in Python also. Okay, so depends on what kind of syntax you need to use, and also what packages you are using. If let's say if some package is not there, you can develop your own package for any of the methods that you are going to utilize. Okay, so we'll just start from some of the basics. So we have seen that let's say this is a variable in which we are storing a vector. Okay, so here what we are doing, so this CLC, if you just want to run one line, just select that line and press F9. Okay, so this CLC will clear all the command window, and if you just select this clear and press F9, see, workspace whatever was there is clear now. You can just write clear workspace also and you can run that line also. Okay, so let's move on to the vectors. So let's say x is a variable in which we are keeping one array kind of thing. So let's say if you run this line, okay, it is running the whole thing. Okay, if you just click on run here, it will run the whole thing. Okay, okay, first I'll clear it again and then I'll tell how to do. So if you just want to run one line, what you will do, you will select that and press F9. Okay, so now see only x is being shown. Now again, if you don't write this semicolon and then if you just run, then you can see that in command window also. So this x is a vector having elements 1 2 3 and 4 as one row. Okay, now if you just want to see that, let's say x1 you are writing as maybe 1 2 3 and 4. See here I have not given any commas and all. Right, now if you run this again, you can see it will be 1 2 3 4. So this means what, even if you don't give comma, it will, if you give space, it will understand that this is the first element, this is the second element, this is the third element, this is the fourth element. Okay, so this is for an array or a, let's say for a vector. Now if you want to add, so x plus 2, this means what, it will have a scalar addition, so this 2 will be added to each of this element. If you just run this line, okay, so here you can see answer. Okay, because we have kept this semicolon, you can see it as answer. If you don't keep this semicolon, you can see, but again if you see this, if you remove the semicolon here, you will get more warnings here. Okay, so just that is just warnings. Okay, those are not errors, but just to see that. So if you just want to see this in the command window, just F9, you can see answer is what, 3 4 and 5 and 6. So 2 is getting added to each of the element of x1. Okay, 3, then 2 plus 2 4, 3 plus 2 5 and 4 plus 2 is 6. Okay, similarly let's say I want to run this F9, and if you now see, we have two vectors, that is x and y. Okay, x is 1 2 3 4 and y is 5 minus 2 3 and 7. Now if you just want to add, you can, it will just add this, that first element to first element, corresponding elements will be added. Okay, just add this F9, 6 0 6 and 11. Okay, now in matrix we know we can do two kind of matrix multiplication. One is the normal matrix multiplication that you know, and also we can do element wise multiplication. Okay, we'll see that first. Now let's say if you want to multiply this, okay, I'll remove this first and then you'll understand properly. So now let's say we have considered one small one variable, that is small z, and we are doing element wise multiplication. So for element wise multiplication, you have to put dot and then you have to put star, and then if you multiply those only, then this two vectors will be multiplied. Now if you see 5 minus 4 9 and 28, so here you see what we are doing, we are putting dot here. This means what, we are doing element wise multiplication. So 5 into 1 is what, 5, minus 2 into 2 is minus 4, 3 into 3 is 9 and 7 4 is 28. Okay, now if we are multiplying this, that is direct x into y, if you are doing, see there should be error, correct. So see, it is showing error using star. So what it is mentioning, that incorrect dimensions for matrix multiplication. Right, if you see this properly, x is what, x is a row vector kind of thing. Right, x is a row vector where what is the order of this, it is 1 by 4. Right, and y is also 1 by 4. For matrix multiplication, the number of columns for the first vector should be equal to the number of rows for the second vector. Right, but here what we are doing, we are just multiplying both the matrix or maybe vectors with 1 by 4 and 1 by 4. That's why there is an error for the dimensions. Hence what we are doing, I'll transpose this. So how we can transpose, either you can directly transpose here. So what we are doing, see this sign, you can see I have, this is for transpose. Okay, so y transpose will make what, either you can store this in one variable. So let's say if you want, maybe a is equals to y transpose. So this one will make the transpose of y and it will keep it in variable a. Okay, just F9. So you see, now you are getting the transpose of y. So y was 5 minus 2 3 7, but in a row form. Here now you are getting 4 rows and 1 column. Now if you just multiply, or you can just write, sorry, x star a, okay, then you will get the matrix multiplication. What will be the order for these matrix? X is what? 1 by 4, and a is what? 4 by 1. So the value or the element will be only 1 by 1, right? So if we just press F9, see, you are getting 38. You can just do that matrix multiplication and you can see. And now you, what is there? This x dot, again, this means that element wise we are doing whatever we are doing element wise. And this is what? This is power, right? So let's say if you are putting that in some variable, b is equals to this, and let's say I'm putting semicolon as in it will come here as an answer, let's say. Okay, so if you just run this, see, b you will be getting here, yeah. So b is what? 1 4 27 and 20, sorry, 256. You just click on this, you'll get, see, so you can see 1 4 27 and 256, right? So x was what? X was 1 2 3 and 4. And so what we are doing, 1 to the power 1 is how much? 1. 2 to the power 2 will be 4, 3 to the power 3 will be 27, and 4 to the power 4 will be 256. Oh, okay, I hope till this it is clear. Okay, so moving on to, again, this MATLAB, if you see, the full form is matrix laboratory. So most of the work that you will see is doing matrix for data analysis, for data visualization, and so on. Okay, this matrix is a very useful thing that you will know if you practice it a lot. Now moving on to the matrix generation. So whatever we did is for vectors. Now let's do some matrix generation and on. So a equals 1 2 3. Again, see, even if you give comma here, it will have the same thing. Okay, 1 comma 2 comma 3, it will create one row vector only. Okay, or the first row, let's say. Now if you want to have a second row, what you will do? You will put a semicolon. This semicolon means what? Next row it will go. So 4 5 6 will be the next row, and 7 8 9 will be the another row. So first row will be 1 2 3, second row will be 4 5 6, and third row will be 7 8 9. Okay, now just select this, or maybe, I hope you will understand. So I'll run both these lines. Just select that, press F9, you'll get a and b. Now you can see a and b here also. A is what? See, a is 1 2 3 4 5 6 7 8 9, something like that, right? Okay, now you want to do matrix multiplication. Okay, now if you don't put this in variable, you'll not see here, you'll see only as answer. Okay, if you just run this, see, answer is how much? Answer is 16 16 16 34 34 34 and 52 50 52. So this is the matrix multiplication for a and b. Okay, here also the answer has been changed from whatever was there to this. Okay, so this, whatever variable, if you don't store it into another variable, it will store as answer, but whatever is the latest one. Okay, now this ones, whatever you can see, ones is used to create a matrix with all ones. Okay, ones 4 comma 4 means what? There will be 4 rows and 4 columns, all the elements will be 1. Okay, and this zeros is used for creating a zero vector. This means a zero vector or zero matrix, let's say. So it will be 4 rows and 3 columns, and all the values in that matrix will be 0. Okay, okay, I'll change the name for this. Maybe I'll write O N, and for this I'll write maybe ZE. Okay, now if you just run these two lines, F9, see, you can see ON. So ON is a, okay, we are multiplying 7 also here. Okay, that's why it is coming 7 into 1 7 into 1. So all the values are 7. Okay, and if you see Z, that is this, see, all the values are 0 with 4 rows and 3 columns. Okay, I hope till this it is understood. Next is I. So this I will do what? This I will create one identity matrix. Okay, and with how many rows? Rows are 3 and columns are 3. Okay, now we have seen this in R also, that if we are, let's say, A, you have created one matrix or something, you are putting that in one variable. Now again, if you are creating another variable with the same name, maybe A is equals to 2. Okay, and if you run this line, then this one will be erased and this variable will have only this 2. Okay, so whenever you are doing, keep different name of the variable, so that uh, variable values does not get updated. Okay, so capital C we are putting as capital C again we are putting as variable in which it will have one identity matrix. So we'll just run this line, we'll see, you can see C is what, an identity matrix with 3 rows and 3 columns, 1 1 0. You can also create one identity matrix but without one square matrix. So let's say if we are writing C1, or let's say C1 equals I 4 comma 3. Okay, whether there will be any solution for this, there will be, but it will not be a square matrix. Okay, F9. Okay, see. Okay, wait, maybe I'll not use number here.
No, sir, you left to select C also.
Oh, okay, okay.
When you are
Okay, 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 I'll write C1 then, otherwise. F9. See, you have how many numbers, how many rows? We have kept 4 rows. Okay, so it will be 4 rows and 3 columns, but here see, one will be obviously in the diagonal. So here if you put a 4 by 4 matrix, then only that last one will come. Okay, it's not like it will not create a matrix, it will create a matrix with one in the I, so wherever I is equals to j, that is in the diagonal, then there it will put 1, other than that it will be 0. Okay, now if you want to just see the diagonal matrix, so what you can use this diag. If you just run this, see. Okay, oh, diagonal of A. Okay, sorry. So diagonal of A is what I see here. If you see A, so A is 1 2 3 4 5 6 7 8 9, right? So 1 5 and 9 are the diagonal. So this is kept in a another variable, that is C, which is a vector now, because it is only considering the diagonal. So the diagonal is this. Now if you want to just see the diagonal of capital C, whatever we have kept, so what will be the answer? It will be 1 1 1. Just to see that diagonal of capital C, let's say. Okay, if you just run this, you'll see C111 you got. Okay, this I10s and all are clear. So this matrix we can use for maybe calculating simultaneous equation. Maybe if you have a list of equations and you want to um, get the solutions for those. Remember, you have used several in class 11 12 also, you have done some Cramer's rule, then matrix, you have used inverse, adjugate and all. So with these also, for those matrix is required for solving differential equation also, you can use matrix, and so matrix is a very important thing. Okay, now coming to the random numbers, so what you can do, you can create a matrix of whatever size you want with random numbers. So here 4 and 3 means there will be 4 rows 3 columns but with random values. So if you just run this, F9, see, we have got, again, why can't you see R here? Because we have put a semicolon. Okay, so if you see R here, see, this is kind of random values has been generated. Okay, so like then you can create a big random matrix also. So let's say RA equals random matrix with maybe 100 rows and 50 columns. That also you can generate. Okay, so if you see here, array will be there. So it also creates a random matrix with 100 rows and 50 columns. Okay, so other than that, we have also in R also we have seen that there are several loops, if else statements.
Sir,
Yes, yes.
this random, it is creating decimal points, not whole number. Is it possible to make it to create a whole number? No.
This random you can't use, but there is something which I have to check. Okay, I'll check that.
Oh.
We can create a matrix with only whole numbers, not decimal. So here you can see,
Using rand.
not rand. There is some
Using
other
rand.
function.
This rand is creating with
Decimal.
decimals.
Yes, yes. It
But
will create only double values.
okay. If we cannot make it to create whole numbers, that rand function
No,
or rand command.
using rand I am not sure. I'll check once, because
Okay,
other function is
okay, sir.
there, which you can create
O-
only integer numbers.
In matrix.
Hmm.
Okay, sir.
Okay. Okay.
Okay, sir.
Okay. So other than that, we have if else statement. All, so whatever we have done in R, we can do it in MATLAB also. So just for knowing, so how, what is the syntax? Only the syntax is changed. In that, what was there? It was like for, it was not written in this format that I equals to 1 is to 7. So here I equals to 1 to 7 means I will start from 1 and it will go till 7. Okay, and then y I as in first it is starting from 1, so in the beginning it will be y1 will be equals to 1 square, then again it will end, it will go, it will be like after 1 what is the come 2. So if you see this 1 is to 7, we can check just to make you understand. Let's say n is equals to 1 is to, sorry, 7. Okay, we'll see, run this line and we'll see what it is creating. Okay, see, in R also you remember that we have created one vector, so starts from 1 to 7, like that here also it is creating one vector starts from 1 to 7. So this 1 is to 7 will create, will start from 1 and will go to 7. Okay, so like I equals to 1, so y1 will be equals to 1 square, then again it will go, it will be starting from 2, so y2 will be 2 square, then again it will go, y3 will be equals to 3 square, and so on. Okay, so I'll just run this. Okay, now if you see, if you can just display y, or if y is there not, y is there, or else you can just display here, you can write sorry, disp and y. Okay, and if you just run this line, you'll get y. Okay, 1 4 9 16 25 36 and 49. Same thing, if you want to see it here, you can see 1 4 9 16 25 36 49 and so on. So similar thing you can do in while loop also, you can use do while also, and so on. Okay, same thing we are doing, but here the syntax is just changed, that y equals to 1, y is less than equals to, till y less than equals to 7 it will go inside, and every time it will have an increment of 1. Okay, so it will also give the same thing. Okay, if you just run this, you can understand. Okay, I'll give some other, otherwise same thing will be again written in y, and then you might not be understand that whether it that is done or not. So here what I did, here I did I cube, this means what, it will be 1 cube, then 2 cube, then 3 cube, and so on. Now if you see the what y only, so see y has changed from, it was like 1 2 something, right? So now 1 4 something something it was there, now it has been 1 8 27 64 and so on. Okay, okay, so we'll move to questions first now. If you guys have MATLAB open, you can just do it. No, not this, this question is done. Okay, this is a simple problem, you can just see and also tell, but if you have a MATLAB open, you can just do it and tell me. You just have to run this following command, these 3 lines, and with that you can tell me. Okay, see, some answer is there. Okay, B, no, yeah, correct, because anyway if you see first E is there, E will have, will be 2 by 4 matrix, 1 2 3 4 and 5 6 7 8, with 2 rows and 4 columns, right? Again what we are doing in the third row and all the elements, what we are doing, we are keeping values starting from 10 to 22. So it will be 10, then again 4 more, that is 14, then 18, then 22. Again it will have 4 elements, that will be the third vector or third row of the E. So if you just forget this question, if you just see these two lines, what it will create, first line will create one matrix with two rows and four columns, two rows and four columns. And then with this line, what will happen, it will append E. Okay, E will be updated, where in the third row it will be updated, and the third row will have the values starting from 10 to 22 with an incrementer of 4. So what will be the matrix E after these two lines? If you run these two lines, the matrix will be 1 2 3 4 5 6 7 8, and the last will be 10 14 18 and 22. Okay, then we are creating one more variable, that is k equals to once 3. So once we know what it will give, it will give a matrix with all the values as 1. It will be a 3 by 3 matrix with 1 1 1 1, something like that. So is k an identity matrix? Obviously not. It will create one matrix with ones only. So if you want one identity matrix, what you should use here, instead of ones, you should use I, right? EYE and then 3. So the correct answer will be no, obviously. Okay, so let's move on to the next question. Okay, answer is coming before question. So find the minimum value of the function using MATLAB or R programming. So given fx is equals to this function, and the range for both x1 and x2 is minus 10 to 10. So before that, in MATLAB I'll show you maybe how to write a functions and all. Okay, just to see all this, okay, whatever I have explained just now, you can see if you just run the first line, F9, see E is equals to 1 2 3 4 4 5 6 8. If you just want to see in the matrix form, you can see it here. See 1 2 3 4 and 5 6 7 8. Now if you just run the second line, what will happen? Sorry, as I said, if you run here directly without commenting here, the whole script will be run. Okay, so I'll clear everything first, 1 minute. Okay, fine. Okay, I have removed everything. Okay, I'm not. Fine. Again, I'll run this F9. So now EA is again created. Okay, if you just want to see that, 1 2 3 4 5 6 7 8. If you just want to see this now, F9. See, now E has been updated, and you can see the third row has been updated, and it will be 10 14 18 and 22. Okay, now if you just want to see the diagonal, you can see the diagonal will be what? See 1 6 18. So diagonal you can't see for a rectangular matrix, right? Only square matrix will have one proper diagonal, so that's why it is only showing 1 6 and 18. Okay, then k equals to I3. This will give what? One identity matrix with 3 by 3 order, so 1 0 0 0 1 0 and so on. Okay, this question is not given in the, okay, fine. I think these questions are there in the assignment, and that's why I did that. Fine. So it was a question, maybe x is given, y is given. Okay, there are three functions, right? And you want to know the minimum. Okay, so x is a we are creating one vector which starts from -2 and goes till 4. Okay, and what will be the increment? Increment is 0.01. Okay, so it starts from -2, then it will be minus 1.99, then minus 1.98 and so on, and it will go till here, that is 3.98 3.99 and 4. Okay, if you just run this line, you'll understand. See, okay, I'll show it here. -2, minus 1.99, minus 1.98 and so on. Okay, and then now we have different function, that is y, maybe let's say some function f1 f2 and f3, let's say. Okay, which I have given name as y, yd and ydd. Okay, so the first function is 3x cube minus 26x plus 6. Second function is 9x square minus 26, and third is 18x. So here what we are doing, x is cube means what? Each element of the x will be given a power of 3. Okay, so that's why we are using this dot. So this dot will do what? Element wise power. Okay, So that's why we are writing this. Okay, any like doubt in writing this function? Because many functions you have written in the R also. I hope there will be no question on this. I'll move.
Sir,
Hmm.
that x value
Hmm.
starting from -2, it will go up to 4.
Yes.
That right hand side table, it is continuing.
Till 4. Yes. If you
Or
see that,
okay, okay,
it will
okay,
go
sir.
till 4.
Okay, sir.
Hmm.
For me, it is not visible. That's the
See
screen.
here also, if you see, it is 1 by 601 double. So 601 values are there in this.
Okay. Yes, sir. Okay, sir. Okay, sir.
Okay. Okay. Should I increase the font? This is fine,
No,
right?
no, sir. Actually, that
Oh, this
scroll
table.
bar
Okay, okay, okay.
is
Okay,
yes,
this
sir.
one you have not seen. Fine. So what we
Okay.
are going to find, we are going to find the minimum of each of this function. Okay. The main was this one only. How to write this? This is now easy. So this z1 is a function which we have to minimize the function y. Z2 we are keeping one variable where we are maximizing the second function, and third like this. So just to find minimum, maximum, you can find mean, mode, median, whatever you want. Okay. So just for that you just need to see what function or what like which function you can use. So for finding out the minimum you can use min. Okay, if let's say here you can see minus values are there, plus values are also there, right? So if you just want to see only the uh, absolute value of this, so for that you can use maybe x, let's say I'll write x abs.
A-
Yeah, so you can just use abs and then x, and if you just run this, okay, you see 1x abs is created, all the values are now positive. Okay, so like that it's there. So if you just want to find out the minimum value of any vector, so here again y is one vector. How many elements will be there in this? It will have again 601 only, because x is having 601 values, so this is only one variable function. Okay, so this will also have 601, so all these things will have 601 variables. So just run this line, I'll run all this once. Okay, F9. So now you can see all y is all this 34 whatever. Okay, and now I'll run all this z1, z2, z3 also. See, you can see here also, you can see here also, wherever you want. So z1 is how much? Z1 is minus 23.4610, z2 is 118, and z3 is 72, something like that. Okay, I hope this min, max, apps and all are clear. Okay. Okay, so one more problem was there in assignment question, I guess. So here you see we have created one vector grd. So these are the grades of maybe 5 students, let's say. It's 11, 18, 26, 9 and 5. Okay, now you are writing pi of grd. So this one will do what? This one will create one pie chart. Okay, so that was simple question, I think, what kind of diagram it will be. So with this pi, it will be pie chart. You can use different kind of this bar plot or histogram, all these things you can do. Okay, so just if you just run these, you'll understand. F9. Now if you see this, you can ask me that here the values are, sorry, kahan gaya? Okay, here the values are 11, 18, 26, 9 and 5, but here if you see the values are not same. Can you tell me why?
They are in percentage
Yeah, correct.
out of.
So any pie chart, it will show total 100%. Okay, so what we are having here, 11 by the total of this, so the percentage is there. Okay, so whatever 26 is there, 26 is how much percentage of the total? It is, okay, it is 38%. Okay, so this 26 is denoting this color is denoted by 26, then this is 18, this is 11, this is 9 and this is 5. Okay, okay, that's it. Then we'll move to the next one. Okay, I think it is sorry. Okay, I need one more function here. we'll see the optimization. So as we have seen that um, this syntax and all, no, if you practice more you will get it much easily. There is some error. This where, okay, this we'll see later then. Fine. So what we are doing now, so we'll move to the functions. Firstly, we can write the function like this also. Okay, so whatever function we are writing, either you can write it here directly in the editor, or you can write the function in any of the other MATLAB file, and then you can directly call those functions. Okay, so let's say I have written one function here. Okay, so this function is having two things. So one is this inequality constraint, and this is equality constraint, let's say. Okay, and the function name you can give anything. Okay, here I have written a non-linear constraint, so for that I have written nlcon. So you can write anything here, so the function name can be your choice. Okay, but the syntax whatever you are writing, just maintain that. Okay, so the function is having two things, that is maybe non-equality constraint and the equality constraint, and the function name I am giving as nlcon. Okay, and x. So now the first equality constraint I'm writing, so this how to write and all we have seen. Just in case, like here what we are doing, x is a vector which is having maybe how many, 4 5, okay, 5 variables or 5 elements. Okay, and in R what we were doing, we were putting this one in third bracket, but here we are putting in the first bracket. Just that is the difference. Okay, so just like that you can write this function. So these are the three equality constraints, and there is no equality constraint, so that's why we are not writing anything. These three constraints can also be written like this, like if you want C equality equals in this third bracket, this function you'll write first, or maybe if you just want that in the, so this can be written in first bracket, and this one will be written in one, then again semicolon, the second one, and then third one. That like that also you can write, or else if you want write, you can write like this also, in first bracket C 1, sorry, C 2, something like that also you can write. So there are other different ways you can write. Okay, so just to show I'm writing here. So this is the function. Now if you want, now you have created a function. Now if you want this function directly, you can just call this function anywhere. Okay, so if you call this function nlcon and write x equals to some x as some 5 variables, wherever x1 x2 x3 x4 x5 values are there, if you just put that, you'll get these directly. Okay, we'll see that in this optim. So before that, just let's see some single variable and multivariable optimization. So before going to optimization, we'll see how to write that and all. So in R also we have seen all this. So we just need to put this at the rate of x. So this at the rate is very similar or analogous to we are writing function in R. Remember, so that is the same here. So at the rate x means it is creating a function with x as a maybe vector, but here we are only putting x, only one variable, so it will not be a vector, it will just be a variable. Okay, so this is a single variable at the rate x square plus 54 by x. Okay, if you just run this, you'll see answer is 55. Okay, like that you can create a multivariable optimization with either scalar units. So here we are putting again two variables. This means what, we are creating two scalar units. So whatever x and y will be there, it will be scalar unit. Now if in the last function that we have seen here what we are doing, we are putting one variable only, but in one variable only there are several elements, that is x1 x2 x3 x4 and x5. So this x is considered as a vector in which 5 elements are there. Okay, so this is multivariable function. If you just want to see the function value at 5 and 4, just run that, see answer will be 520. Okay, and similar to whatever we have seen in the plot, we can create one x line as in R we have seen AB line, like that we can use x line, reference line and y line. So x line will create one line at x equals to 2.5, y will create a function at y equals to 1.5. Then reference line as in this will tell you the slope and the intercept. Okay, and based on that a line will be created. Okay, So all these things has been done in the class, so I'm not moving that much. Okay, if there is any question in the assignment question, we'll see that. Yeah, so this one was there, right? So anyone is having MATLAB open? If not, I'll do that. Sorry.
No, sir, I didn't install till now. Did you
Okay.
explain, sir, how to install in the beginning of the lecture?
No,
Today
no,
I
no.
couldn't
Installation is there in the like, I mean,
video,
lectures.
lecture
Yeah, yeah,
video.
yeah, yeah. You can.
Okay, sir. Okay, sir.
So if you don't have organization which is giving you MATLAB is a kind of paid thing. So if you just want to have a free kind of thing, you can use that for 1 month. Okay. So many people,
Which one, sir?
this MATLAB only, MATLAB is kind of
Okay.
paid thing. So this free version you can use for 1 month,
Okay, sir.
online version of MATLAB.
Okay, okay, sir.
Okay.
Sir, how the questions will be asked in exam based on this, or this is only for our practice?
This is only for practice. So whatever you have seen in your assignment questions, right?
Yes, sir.
Similar kind of question will be there. It will not be like
Mm.
a big code will be given and then you have to write. Whatever you're doing in your assignment question, similar kind of that will be there in the
So
exams.
MATLAB questions also will come in that case
Whichever you can do in the like by hand.
without.
Last question we have seen, right?
Okay.
Where is that?
Yes, sir. Yes, sir.
Arey
Like
yaar.
that questions only.
Questions like that
Without
will be there
using.
without using
Okay.
MATLAB and all. Yes.
By our
Yes,
understanding,
yes,
the
yes.
command understand. Okay,
Yes,
okay,
if
sir.
it can be done by hand, then only it will be
Okay.
given. This question will not come because it is having 8 to the power 8 and
Yeah.
all. Okay.
In our code also same. The
Same, same, same.
questions will come based on our
Yes,
understanding.
yes, yes.
Okay,
Okay.
sir.
Okay. Okay. So you can just do this. Okay, I'll only do then. 2x to the power 8. If I have written this, I'm check. If these things, okay, I'll just go through this once. So this we have just seen that x minus 1 is to 0.1 to 1. This means what? It will create a vector starting from minus 1 and go till 1 with an increment of zero point 0.1. Okay, and then if you just create a function, this all we have seen in the last script only. So if you just want to plot, you can just use plot. See, you can see the plot. Okay, now if you want to just increase this, you can increase the x, you have to increase, right? Because you know this function will go like this. You have seen this function in R also. So just for that, I'll change this from minus 2 to 2. Okay, you can see more smoother version. What happened? Yeah, so you can see now minus 2 to 2 and it is more smooth. So based on that, you can just see. Okay, this plot and all. Now on the same plot, if you want to do plot, you can use this hold on. Okay, now unless until you are keeping it off, all the plots that are there, it will be on the same plot. Okay. mm, so if I just do all this, so see, so first function was y1 is equals to sine x, so sine x is created. Okay, next we are keeping it a title of combined plots. Now we are starting hold on as in this plot will be there. After that, whatever function we are plotting, it will be on the same plot. Now let's see if you want to create one more function, y4 equals to maybe cos x. Okay, and just plot. So you can plot anything, you can plot scatter plot, you can plot histogram, okay, whatever you want. Y4, now with this, plot y4 as in it will plot a line plot or whatever. If you just now run this, as because I'm not closing the figure, it is not coming. Okay, so because cos x is coming, no, so it is going like that. This is the cos x one. Okay, I hope this is clear. And yeah, if you want to comment, you can use this percentage button. 1% is also fine, just to understand where we are, at what section we are putting that many comments. Now if you just want to maybe comment all this line at once, what you can do, maybe in Python Jupyter Notebook, if you see control slash will work here. If you press control R, all the lines whatever was there will be commented. Okay, if you again don't want this comment, you can press Ctrl T and again it will go. Fine. Okay, now coming to optimization. Okay, so whatever in this week 11 lectures are there, the optimization is only with classical optimization that we have studied in the very first lectures till week 6 or something. Okay, so what we have the objective function, that is x square plus 54 by x. We don't have any constant, only that x1 starts from x1, so we need one initial consideration, remember, in the classical optimization, and hence we are creating one initial values for 1 and 2, x1 x2 0 and 11, and then you can give these options and on. So for this you can use f min b and d. Okay, so just if you want to just see this, all this we have seen in the class. Okay, see, so these are the iterations. So iteration went to maybe 9, and the points are going like this and this, and then getting stable at maybe 27 or something, I don't know. You can see that, yeah. So so with this disp it will display, okay, like the like print we would, print we didn't do print in C, we do print. Okay, like that we are using disp to display the value. So here what we are displaying, we are displaying x. So x is the value at which function will be maximized or minimized, whatever we are doing. Okay, and this will be objective function. So objective function, if you write f1 here, you should write f1 and then x here. Okay, so like that the function value is 27. Okay, next, similar to that we can do the multivariable optimization. Okay, so I'm not doing all those, all this done. Okay, I think this one was there in the question. Okay, I'll clear it first, or else fine, let it be. See, now for this function, that is 2x bar 8 plus 4x minus 25, this one was the question, I guess. I think yes. No, where was that? Yes, this one was the question. 2x over 8 plus 4x minus 25, and the range starts from minus 10 to 10. Okay, we'll go to this. Where is that? MATLAB.
No, sir, that question is not there. 2x bar
2x bar 8, 4x minus 25. What was that? This one was different. Same question only. Okay, and x1
in week 11.
Yeah, week 11 only, I think.
That question is not there. Okay, no problem.
That question is not okay. Wherever I have seen from somewhere, I have taken this question. So the function is 2x bar 8 plus 4x minus 25. Okay, and x1 is minus 10, x2 is 10. So this is the lower bound, this is the upper bound. Okay, and this x1 and x2 are the, okay, so x1 and x2 we are keeping it as, okay, this is one variable question only. Okay, I think this is one variable question only. Let me check.
Yes, sir.
So one variable question only. This is the lower bound, this is the upper bound. Okay, so the question there I have written wrongly, I think. Okay, here it should not be x1 x2, it should be x1. Yeah, x1 is minus 10 and then x2 is 10 initial values. Okay.
Okay, sir.
So many tabs. Fine. So if you just run this, if you want to display the x value is how much? Minus 0.82, and the optimized value is minus 27.8712. So the correct answer for this will be minus 27.87. Okay.
Okay, sir.
Like that you can do constant optimization also, but there you will use f min. Where is that? Okay, I'll show. Yeah, so you'll use f min con. So here you can use f min con for where you have constraint optimization. Okay, so these things and all you have anyway in the lectures, it is explained properly, so I'm not going to explain it. Okay, so like that, these are for the here you can see one thing I wanted to show. Where is that? NL con should be there. See, so here we are making one variable, but we are calling at the rate nlcon. This nlcon I have created in some other MATLAB file here. Okay, so if we are calling directly at the rate nlcon, this means the whole function is getting called. Okay, and hence we are having, or else if you just want to write the whole function here also you can write, no issue. Okay, so for here we have only one function and hence we don't have any problem. So when we are creating one package, let's say if you are using this, whatever this f min con is there, so this is again a function from a package, and creating a package there will be different several equations, several functions. So for that, when you are having lot of functions, then we do, we create different MATLAB files so that we can directly call that, and whenever we want to call we can call that. So for that we create a new file for that and make a function in that. Okay, like that, and then you can just do it. Okay, I hope the questions also is, I have not given more questions this time. Yeah, that's it. Okay, and that's it. Any questions? If you have any questions you can ask. If you have any doubt in the assignments also you can ask.
Sir,
Hmm.
get into PC through that. If I download and install, will it be a problem for the system or
Sorry, can you repeat once?
MATLAB
Hmm.
software
Hmm.
from getting there is on website get into PC.
Hmm. Hmm. Hmm.
From that, if I download and install,
Hmm.
is it okay or
No, I'll suggest you to use the online version of MATLAB if your organization does not have this MATLAB license.
okay, sir?
Okay, if you have license then
Okay.
you can do that. Get into PC whatever you are saying. Okay.
In our lab, they have installed.
Uh-huh.
They may have the license.
Yeah, if
That will be for
license.
only limited user or
No, no, no. For organization, if they have taken license, it will be a full-time license, I guess.
okay, sir.
If you personally want to use, you can use that for 1 month online version.
Okay, okay, sir.
Hmm. Anyone? Any other questions? Any questions from R and all? R is almost over now.
Yes, sir. We have practiced.
Uh,
Assignment I have submitted.
okay, okay,
Mhm.
okay, fine. Okay, then if there is no, but I'll check this. Okay, okay. If there is no question, I'll stop it. I'll upload this now only. Okay. Thank you. Thank you so much.
Okay, sir.
Mm,
Thank
bye.
you, sir.
Mm.
Thank you, sir. Thank you.